Okay, so more problems related to similar triangles. Determine whether the triangles are similar. If so, write a similarity statement and identify which triangle similarity theorem is used. Okay, so I have these two triangles here. Are they similar? Let's take a look. Suppose that TV corresponds with WY. Let's try that. So TW over WY equals 10 to 20. So that's 1/2. Great. And then we're going to try 11 to 22. Do not say 22 over 11 because since I use 10 to be my numerator and it's part of this triangle, you have to be fair and say, okay, well, 11 should also be the numerator. And then you're going to put 22 in the denominator. So ZW over WX equal that 11 over 22 reduces to 1/2. So you can see that you have a 1/2 here and a 1/2 here. Those corresponding sides should be proportional to each other. Or in other words, I see if you have those, ratios that are equal to each other, then they should be, proportional. And okay, is this enough information to tell me whether or not these two triangles are similar? No, we just have two ratios that are equal to each other. Not enough information. I have to look at one more thing. And you guessed it, if I zoom in, these angles are congruent. They have to be. Because of vertical angles. So these two triangles are indeed similar. So they are similar because of the side angle side similarity theorem. So I say, okay, triangle TWS is similar to triangle YWX. Okay. All right, so let's take a look at these two figures here. I'm going to go from small to big. So IJ is equal to HF. Oh, no, sorry. IJ over HF is equal to 4 over 6, reduced to 2/3. Okay, and then let's see, IK over, so I have a 5 here. Notice that I was going, small number to small number, and 5 is the medium number, so it should be 7.5. So IK over HG is equal to 5 over 7.5. Does that give me 2/3? Using my calculator here, so 5 divided by 7.5, hit enter, press math, frac, enter, 2/3. Great, I'm off to a great start. I have 2/3 here, 2/3 here. Will 6 over 9 give me 2/3? Let's see. So I have JK over FG. So 6 over 9 reduces to 2/3. Nice. So that means that all of the corresponding sides are proportional to each other. So what does that mean? Are they similar by angle-angle similarity, side-angle-side similarity, or side-side-side similarity? Well, we're dealing with sides here. They're proportional to each other. I'm going to say triangle IJK is similar to triangle FHG by the side-side-side similarity theorem. Number 16. Okay, are these two figures similar to each other? I got parallel lines, so you know for sure they're going to be cut by a transversal. So angle U is congruent to angle S, and angle V is congruent to angle R. So angle U congruent to angle S, and angle V is congruent to angle R. These two figures here are congruent to each other by the angle-angle similarity. So I can say triangle VUT is similar to triangle RST by the angle-angle similarity theorem. All right. 17 says if M and PQ is similar to XYZW, find the scale ratio of those two figures and the perimeter of each polygon. Recall that the scale ratio is proportional to the perimeters of the two figures. What I like about this problem is that we can assume that these two figures are similar because why? It's already stated. So, first of all, I need to figure out my scale ratio. I'm going to go from the small to big. WX has a number. It's 4. So if I look, okay, so WX corresponds with QM. So here's QM. So WX to QM is equal to 4 over 8, which is 1/2. So that's your scale ratio. So I do 1/2 equals the perimeter of the smaller figure, which if I were to add up all the sides, you can't because there's a blank here, here, and there. So we don't know what the perimeter of this thing is, so we're going to call that X. So P is equal to X, but here you can add up the sides easily. So you should get, trying to figure out what the perimeter of that is. That's P equals 34. Great, so I can write X to 34, cross multiply. That's your perimeter, 17. Determine whether segment BC is parallel to segment DE. Justify your answers. It's super important to label your figure because 18 has it all. AD is 15, DB is 12, AE is 10, and EC is 8. So what you're going to do is you're going to do part over part equals part over part. You're going to cross multiply and see whether or not the cross products are equal. If the cross products are equal, that's enough to tell you, hey, these two segments are indeed parallel. So I'm going to do 15 over 12 equal that to 10 over 8. Cross multiply, 12 times 10 equals 8 times 15. 12 times 10 is 120, and 8 times 15 is also 120. So we do have the left-hand side equal to the right-hand side. So yes, segment DE is parallel to segment BC. All right, so 19, we're going to use that same figure. I'm going to have to use a different color for this so I won't confuse you. So AE is 30, AC is 45, so this whole thing here is 45. And then AD is 2 times DB. So AD is 2 times DB. Y'all, do we know what DB is? We don't, so we're going to call that X. So DB here is X, and AD is 2 times X. So then I can go ahead and see whether or not if these two figures are, or not the figures, I'm sorry, if two segments are parallel to each other. So I'm going to do part over part equal that to part over, there's nothing here. I have 30. This whole thing is 45. If I apply the segment addition postulate, part plus part equals a whole, you should be able to figure this out easily. So part plus what is equal to 45? That should be 15. So let's do it. 2x over x is equal to 30 over 15. So I have 30x equals 30x. The left-hand side equals the right-hand side. So yes, segment BC is parallel to segment DE. Segment JH and segment HN are mid-segments of triangle KLM. Find the value of x. So recall that the mid-segment is equal to 1/2 the third side, or the side parallel to the mid-segment. So segment JH is parallel to segment LM. Now, if LM is 30 and the mid-segment is half of 30, well, x should be 15. For 21, I have JH, which is the mid-segment, that's 9. And since we already know what the mid-segment is, we don't even know what the third side is. So that means I need to double this, so 9 times 2 is 18. So x is 18. Okay, so find the missing variables, round to the nearest tenth if necessary. So number 22 has a triangle with 2 lines that are parallel to each other. And we can see that this part is congruent to this part. So since those 2 parts are congruent, I can actually set them equal to each other rather than having to create a proportion. And even if I created a proportion, well, you're going to have an x over y equals x over y, which we don't want, right? Because that's impossible to do. So I think the best choice is to set these equations, or not equations, set these expressions equal to each other and then solve for x. So that should give you x is equal to 9.5, and then I'm going to look at these 2 parts here. Because we have a triangle and these lines are parallel and these segments are congruent, then the result of that would be, okay, these segments or these parts are congruent to each other. So 4y minus 7 equals 2y minus 1. So I get y equals 3. Great, so for this one, okay, what do I have to do? Because that this segment is perpendicular to this segment, these angles are 90 degrees, and that means that all of these should have the same slope. Therefore, these lines have to be parallel to each other. So now I can, take these 2 segments, equal them to each other, and I get 8 equals 16x, so x is 1/2. And then over here, I can set those 2 segments equal to each other. So 20y minus 2 is equal to 17y plus 3. So 3y minus 2 is equal to 3. Therefore, 3y is equal to 5. And then I get y equals 5/3. It's asking me to round, so y is equal to 1.66, so 1.7. For 22, we have part, and part, and we have a triangle with parallel lines, segments here. Parallel segments. we're going to use a triangle proportionality theorem where I do, again, part over part equals part over part. Then I cross multiply. And then I get, what, 5x is 48. So x is equal to 48 over 5, or 9.6. Number 25, I got a triangle within a triangle, so I'm going to redraw. So I have the small triangle, and then I have the big triangle. So I have 8, and this is 10. We don't know what this is. And then we got, what? We got 18 plus 8 is 26. And then I got 10 plus x. Okay? Or, I don't know why I'm doing this. You can also just say these segments are parallel because this segment and this segment, they intersect at a 90-degree angle. And that means that if this is, so this segment intersects this segment at a 90-degree angle, that means that these two things should have the same slope. So you can do 8 over 18, which is equal to 10 over x. For this, you can do 8 over 26 equals 10 over 10 plus x, and you should get the same answer. But this looks a little complicated, so I just showed you unintentionally what ways that you can approach this problem. So let me do this because I can say, oh, okay, 8 times x is 8x, and then 18 times 10 is 180. So x should equal 22.5. Got some word problems here. So when Alonzo is 5 feet 9 inches tall, stands next to a basketball goal, his shadow is 2 feet long. So 2 feet long. And the basketball goal's shadow is 4 feet 3 inches long. So about how tall is the basketball goal? Remember that you need to switch the inches into feet by dividing the inches by 12. So here I got, 5 feet 9 inches. And then here I got 2 feet. And here I have 4 feet 3 inches. So I can go ahead and convert that. So I have 5 points. So that 5 feet or 5 point, they should remain the same because we need to convert everything into feet. This 9 inches though, I'm going to do 9 over 12 just like what it says over here. So 9 over 12 is 3/4 or 0.75. So I say 5.75 for that one. And then we got the 2 feet, that stays the same, but this 3 inches over here, we're going to convert that. So it's 3 over 12 or 1/4. So now that becomes 4.25 feet. Okay, so let me go ahead and draw Alonzo. And he has a shadow that's 2 feet long. So it's 2 feet long. And he is 5.75 feet tall. And I got this basketball goal.
Do you guys have to go to the new house right away, or do you have some time?
We don't know how tall. We don't know how tall the basketball goal is, so I'll call it X. But we do know that its shadow is 4 feet 3 inches, or 4.25 feet. So then I can go ahead and say, I can take these two things and create a ratio with them. So I have 5.75 over X is equal to 2 over 4.25. So then I can cross multiply, and I'm left with what? 5.75 times 4.25. Wow, you will get 24.4375 equals 2 times X is 2X. So X is 12.21875 feet. It doesn't tell me it around here, so you can do whatever you want. You can say X is equal to 12.2, or X is equal to 12.21, or you can just give me this whole answer here. But if it tells you it around, you need to pay attention and do what it's asked. So please keep that in mind. Okay, number 27, it says the measures of the angles of a triangle are in a ratio of 2 to 3 to 4. Find the measures of the angles. Now, again, like in class, I did say that the measures of the angles of a triangle are in a ratio. It doesn't say that the angles are strictly, or the measure of the angles are strictly 2 degrees, 3 degrees, 4 degrees. That's not what it's asking. It's saying the ratio is in the form 2 to 3 to 4. So if I were to draw my triangle, I should say 2x, 3x, and 4x. And you know that the sum of the interior angles of a triangle is always 180. So 2x plus 3x plus 4x is 180. If you combine the like terms here, you should get 9x equal to 180. So dividing, x is 20. So let's go ahead and plug 20 into the original. So 2 times 20 is 40 degrees. 2 times 4x, or 4 times 20 is 80 degrees. And 20 times 3, or 3 times 20 is 60 degrees. So 60 degrees, 40 degrees, and 80 degrees are your answers. 28. The sides of quadrilateral are in a ratio 3 to 5 to 8 to 11, and the perimeter of the quadrilateral is 108. Find the length of the shortest side. Okay, so with a quadrilateral, we have 4 sides. And that means that we have to add these, that should be, there we go. So we're dealing with 4 sides. They're in the ratio form. So I'm going to do 3x plus 5x plus 8x plus 11x equals, well, the perimeter here is 108. So, combining the like terms, I get 27x equals 108. So, x is 4. And I'm going to assume that 3x is my shortest side because it's the smallest quantity in this ratio here. So 3 times 4 is 12 degrees. That's your answer.